Hi everyone, today let's solve the problem number 232. Implement queue using stacks. So this is easy question. They have mentioned here easy. So let's do one thing. Let's see what the question states here. We have to design a this one FIFO queue using only two stacks, right? So we have to design FIFO queues only using two stacks, sorry. Four operations are supported here. You can clearly see four operations are supported. One is, just give me a second here, 1 second, just give me a second here. Yeah, here we have been given four operations. One is push, another one is peek, another one is pop, and another one is empty. My queue is nothing but the initialization part here within the code. So here we have been given four operations. One is push, pop, peek, and empty. Push, pop, peek, and empty. These are the four operations that we'll be making use of, right? So here supported operations, and we have to use only standard stack operations. So we have to go with the standard stack operations. Again, we shouldn't go with a this one array dq, right? So we have to go with the standard stack operations here. Now what are the standard stack operations here? This one, push pop, push pop, peek and is empty. Push pop, this one, peek and is empty. These are the four standard this one what do we call stack operations that we'll be making use of, or we should make use of. Basically, what are the operations? Push, pop, peek, and for the empty it is empty. For the empty it is empty, right? So these are the four standard operations that we should make use of, or we should be making use of, right? So they have mentioned in the question strictly. We have to simulate queue behavior where the front is removed first. We have to simulate queue behavior where the front is removed first. We shouldn't use built-in queue. No use of built-in queue or the linked list. So only two stacks allowed. So again, they have said it clearly here. We shouldn't be making use of the built-in queue or the linked list. So only two stacks allowed. So we should be making use of the two stacks for this problem. So again, so the approach will be quite obviously you would have accordingly with the question only will go. So we'll be making use of the two stacks here, right? So we will be making use of the two stacks because they have mentioned not to use built-in queues or the linked list here in this case, right? So only two stacks are allowed. So we will be going with the stack approach, right? So we'll be making use of the stacks, mainly two stacks, right? I hope the question part is completely clear. Let's come to the approach part now. Let's consider the first example. Let's consider the first example. I hope the question is completely clear, whatever we need, right? So we are supported with the four operations. One is push, pop, peek, and empty. Also, we have to go with the this one. These are the four supported methods basically, right? So here, see, pop, peek, empty, and push. So one more thing, here again, initialization part return value is null, and the push also. So we are just pushing the value to the this one. We are pushing the value to the stacks using the push. So basically, there is no return value. We don't have to return anything. So this will be return value will be null. For this initialization part also, return value will be null. For these two, return value will be null. Only for these three, right? Pop, peek, and empty, the return value for the pop and peek will be number, and the empty will be boolean value. Either it can be true or false. Here in this case, it will be number. So the return value of pop and peek will be number, and the return value of the empty, right? Empty is, what do we call this one, boolean value, either true or false. Either true or false. Just keep this in mind, right? So let me do one thing here. Yeah. So here what we'll do here, first thing, let's discuss the approach followed by the complexities, and then let's write the code. So here we have been given my queue of this thing, nothing but the initialization part here. This one has to be null. This is fine, right? Next we are going with the push operation. Here we are going with the push operation. So first of all, I have said we will be making use of the two stacks. One is in stack and out stack. So let's make use of the two stacks. One is in stack and one is out stack, right? Just remember this, we'll be making use of the two stacks. One is in stack and one is out stack here in this case, right? So first step is we have to push the this is data, right? We have to push the data one. We have to push the value one. Basically, data consists of the value one. Here we have to push the value one. Push one into in stack. So we are pushing 1 into the in stack. So let me write here in stack. So let me write here out stack, right? So this one we are pushing 1 into the in stack first, right? So now in stack consists of the element 1, right? Now in stack consists of the element 1. Now we have to push the element 2 to the stack. Now we have to push the element 2 to the stack. Again we will push 2 into the in stack. Now in stack consists of this one, two elements. One is 1 and 2. One is 1 and 2. 2 uh, this one stack operations basically follow last in first out, right? Last in first out, right? So here in this case, last, as it follows the last in first out, so we have two at the end and one at the beginning, right? So I hope this is clear. Next we have to perform the peak operation. Here we have been given peak of this one empty array. This is fine. Peak operations we have to perform means we have to move all the values from in stack to out stack. Nothing but we have to perform this one. Uh, we have to perform the peak operation here, right? So we have to move all the elements from in stack to out stack. So out stack consists of now 2 comma 1, 2 comma 1. So last in first out, right? So we will be moving 2 to first, this one here, in this case 1. So when we move all the elements from in stack to out stack, the out stack consists of the elements 2 and 1, not 1 and 2, because stack follows this one, LeetCode. Stack follows LeetCode, last in first out, right? So I hope this is fine. I hope this is fine, right? So next step here is we have to go with the pop. We have to perform pop operation, right? So we have to perform pop. So we will do one thing. So we will do one thing. We have to pop from the out stack. So we have to pop from the out stack. So as I've said, last in first out. So here in this case, um, we have to perform pop operation, right? So we have to perform pop operation. So what we'll do here in this case, we will remove this one. We will remove this one, last in first out. So this one we will remove. Here in this case, one will be removed. So one came first, right? So when we this one moved element from this one to this one came first and the second two came next, as we are making use of the stack. Here we will remove one. After removing one, so this one, what do we call, out stack, consists of the element 2. Out stack consists of the element 2 here, right? Out stack consists of the element 2 here. So we are left with the element 2, and in this case what we removed or what we popped, 1. So we have to return 1. So according, we need to return 1, and in the queue we are left with the value 2. In the queue we are left with the value 2, right? Out stack consists of the value 2, the element 2, right? So I hope this is clear. Then we are finally left with the empty operation. So empty operation, so we'll go with the, we'll check whether the stack is empty or not, whether the stack is, both stacks are empty or not. See here, this consists of 1 comma 2. We are not performing any operation here, and we'll check for out stack as well. Out stack consists of the element 2. As we have popped only one, out stack consists of the element 2. Both the stacks are non-empty. Both the stacks are non-empty. It consists of the elements, in stack consists of the elements 1 comma 2, and the out stack consists of the element 2. Both are non-empty. So what we will do, we will return the boolean value false. Here we'll return the boolean value false, not the true. In this case we will return the boolean value false, right? So here in this case, yeah, we have got the output. So this one, null, 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 and 1, 1 and false, 1, 1 and false, right? So here I hope this part is completely clear. So this one we didn't discuss, I think. So here the peak part, Peak part also we have discussed, right? So here we are moving the all the elements from in stack to out stack. So we get 2 comma 1. So we will peak 1. We will peak 1. So we will pick 1 and again. So we are left with 2 comma 1 again. So we'll pop 1 because the last element last in first out stack follows last in first out. So when we remove 1, so we are left with 2 and we have to return 1. So that is how we got 1 1 here. Finally, we'll check whether two stacks are empty or not. No. In the in stack we are left with 1 and 2 elements, and in the out stack we are left with the element 2. So this will be false, quite obviously, right? So this is how we got the output: triple null, double one, false, right? So I hope the approach part is completely clear. Now, as we are completely familiar with the approach, let's write the code. Before writing the code, I just want to tell you one thing. Let's discuss the complexities and then let's write the code, right? So what would be the time complexity? Here, the time complexity for the push operation, this one I'm speaking of. So just give me a second here. This one, the time complexity for the push operation would be big O of 1. The time complexity for the push operation would be big O of 1. Um, and pop and peak, this one I'm speaking of, the time complexity for the pop and peak will be big of 1 as well. So for this also, the time complexity would be big of 1 because we are shifting only once per the element, right? We are shifting only once per the element. I hope this part is clear. And what would be the space complexity here? The space complexity would be big of n, quite obviously. Why? Because in the worst case we have to store all the elements across the two stacks, right? So n is nothing but here number of elements that is stored across two stacks. So in worst case we have to store all the elements in the across the two stacks. So the space complexity would be big of n, and the time complexity of push, pop and peak would be big of 1 here, right? I hope the complexities part is completely clear, right? So next, as we are completely familiar with the approach and complexities, we are good to write the code. Let's start writing the code. Let's start writing the code. So first step here is let's initialize the two stacks. Let's make use of the create two stacks first, in stack and out stack. Before initialization part, let's make use of two stacks. One is to handle the push operations and another one to handle pop and peak operations, right? So here let me go with, so not here, basically this is not the initialization part. So we are creating stacks here. So this will be stack of integer. So we are going with the standard stack operations or the standard stack. Yeah, standard stack, not the array dq here. So array dq can be made, we can make use of the array dq basically for the stack and queue operations, right? For the faster operations, right? Basically for the optimization part. So here will be, we have been asked in the question to make use of the standard this one stack operations, right? So we have to maintain the two stacks here in this case. So let's go with stack of integer. So here this will be in stack, this is fine. And the next one is same thing. Let me copy the same thing here and let me make the necessary changes here. Instead of in, let me give out. This is fine. In stack and out stack. So next step is the initialization part. So we have to initialize the input stack and the output stack. So I'll just go with in stack equals. So we are initializing the input stack here. This will be new stack. This is fine. So the next one here is we have to initialize the output stack as well. So I'll just go with out stack equals new. So this will be stack. So this is fine. So we are done with the initialization part. Next is push. Next is push. So we have to always push the new element to the in stack, not the out stack. So out stack is nothing but the output stack. We have to always push the new elements to the in stack. So this is nothing but in stack of this one. In stack will be making use of the push operation of x, the parameter x they have mentioned value. So basically return value still false, I mean null for these two. Return value still null for these two. So let's go with the pop. So return value for the pop and peak is number and this one empty is boolean value, right? So let's move on with the pop method here. So here we have to always push the new elements to in stack, as I've said, right? So the next here within the pop method, we have to ensure elements are in the correct order and then pop from the front of the queue. Then we have to pop from the front of the queue. first let's ensure elements are in the correct order. So let's make use of the shift stacks here. Let's make use of the shift stacks here. This is fine. We have to ensure that the elements are in the correct order. Then we have to pop from the front of the queue. Then we have to pop from the front of the queue. To pop from the front of the queue, we will be doing that in the out stack, not the in stack. So here I'll be uh, same thing. Let's articulate in the form of code. Return here what we need to return. Return out stack will be making use of, as I've said. So this will be out stack dot pop. This will be out stack dot pop. This is fine. So let's move on with the next step here. Let's move on with the next step. So next method here, pop. So we are done with the pop itself, right? So let's move on with the peak. Sorry. So again, here the same thing. We have to ensure the elements are in the correct order, and then we have to peak the front of the queue. Then we have to peak the front of the queue. Same thing, same. This one will be same exactly as this, but instead of a pop, we'll be making use of the peak. Shift stacks remains shift stacks itself. We are picking from the out stack itself. Will not pick from the input stack. We'll be picking from the output stack. So instead of pop, we'll be making use of the peak here. The only difference, right? So we are ensuring the elements in the correct order. Then we are picking the front of the queue. Next step is empty. Here next step is empty. So one thing you would have this one noticed here, we have made use of the shift stacks here, right? So we are ensuring the elements are in the correct order. So basically this is the this one, what do you call, helper function, so which I haven't written. I've completely forgot, man. Let me write this one. Don't get confused. So here I have made use of the shift stacks already, so I haven't written the helper function at all. So how am I making use of this one? This is not the, this is not some operations that is provided by stacks, right? So I am making use of some function, helper function basically, and I am using it within this method. So let me make write the helper function, and then finally let's move on with the empty method, right? So now for now let's write the shift stacks, this one helper function. So I'll just go with private, sorry, not private, this is private, this is void, and the name we have given is shift stacks. So this is fine. So within this function, what we'll do, we have to shift only when out stack is empty. We have to shift only when out stack is empty. So if out stack, let's go with the is empty, then what we will do, let's write the simple while loop here. While not of in stack dot is empty here. So for this one, within this while loop, what we'll do, we'll reverse the in stack into out stack. We have to reverse the in stack into out stack. So I'll just go with here out stack dot push of in stack. So this one has to be capital S here. In stack dot pop. So we are just reversing the in stack into out stack, or we just have to reverse in stack into out stack. So this is it for the this one, what do we call, shift stacks helper function. Next, the same thing, we have made use of this function within this method, peak method, right? So peak and pop method. So this is fine. The final step here is, let's move on with the empty method, the last one. So here, if queue is empty, means if the both stacks are empty, then only we have to return true, else we have to return false, right? So let's articulate the same thing in the form of code. Return is stack, I mean, sorry, yeah, in stack, not the is stack. We'll be considering in stack, right? Why did I write is stack? This is fine. So this has to be is empty. We are checking, and both stacks will, we have to check for both stacks, right? So we have to check if both stacks are empty, nothing but queue is empty, right? So here in this case, we are simulating the queue using stacks. We are implementing queue using stacks. Basically, we are simulating queue using the two stacks basically. So I'll just go with out stacks. So here in this case, out stack dot is empty. So this is fine. So let's make this one capital E. Oh, so this, I hope this part is clear. Right, let me format the code once. Let me format the code once. Let me do one thing. Let me remove this one so that this looks good, clean, right? So that this looks clean. So yeah, this is it for the code. I hope the coding part is completely clear. Let's run the code. Sorry. So here, uh, what we have got, outstack dot is empty. This has to be capital E, right? So in the line number 30, just give me a second. So yeah, let me do one thing. Let me go with capital E instead of the small e. So let's hit the run button. So here you can clearly see the sample test case is getting passed. So let me hit the submit button quickly. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct in this case, right? Whatever the code that we have written works absolutely correct, right? I hope the solution part is completely clear along with the approach and the complexities, right? For now, this is it. Thanks for watching, guys.